Hello and welcome to Sean White's Solar and Energy Storage Podcast.
Today, our special guest is coming back for his second time around, and it's Matias Sigal, and he is coming all the way from the other side of the world. What's happening, Matias?
Hi, Sean. Great to see you again. It's going great. Lots of development. The solar industry in the US is having a huge change, and we are riding the wave.
All right, yeah. It's like kind of crazy because a lot of times when things go up and down, that's when the winners come about. One of the things that I noticed, it just like my business of doing a lot of online training, is the best thing for it was a disaster, was COVID. And it was like before COVID, people were not as sure about doing online training and things like that. And then they found out like, wow, this is great. I could do it at my own time. I could do it whenever I want. I could take a break whenever I want. I could rewind and do things over and over again. So some people were accusing me of causing COVID just because it was good for my business. But it lasted too. It's like people just have a different mindset now about doing things online. So we can see things that a lot of times people think like, oh, this is going to be terrible, but then we could make the best of it. So how are you making the best of it?
Yeah, so, well, basically, I'm specifically talking about two main changes, maybe to put some context, the One Big Beautiful Bill Act and the energy demand increase, mainly based on data centers and industry, which in fact is curious that is exponential, like it's the biggest increase in demand since the end of the Second World War, when the soldiers went back to the US. And we open a new segment, a new module for the company to help do M&As of solar farms and storage projects and data centers, which is booming. So that's why I was saying to ride that wave.
Yeah. Okay, great. So you're dealing a lot with the data centers and the solar, the renewable energy storage and all that. So how do you see that growth too of the data centers? Like, how is that growing?
It's booming. So, well, basically, like on one hand, most big tech companies are announcing this huge development of mega data centers, but also there are a bunch of smaller developers that are also deploying new data centers. There is a similar challenge than in renewables, that is the access to the grid. So that dictates the velocity of these new projects to come live. But we see this booming in a exponential way, and maybe like a good validation is you see most developers, solar developers, signing deals with the big tech, like with Google and Amazon and Meta, to provide them with power. And so now these two industries are quite similar in some sense, so they have a lot of synergy.
So like with all this, I hear a lot about it, the growth of the data centers and all that, but how much is that? Like, I guess it's probably regional. So in certain areas, it's a big thing, and other areas, it's not as big of a thing. But like, would you say that do you have any statistics on that? Like how much more energy demand there is, like maybe like overall in the whole country or in certain areas?
Yeah, so, I mean, the US, basically the stat is that the world is projected to grow until 2030, 10% year over year in terms of data centers. But this also relates that, and this is even data before of the AI boom, like even 3 years ago, there was this projection that data centers will consume 10% of the energy generation by 2030. And this is totally related because, as you know, they are big energy consumers. So that's why these two words are together and super related.
And so like, I mean, that's a lot, 10%. Are the data centers more regional though? Are they like in certain areas, I guess?
Yeah, so you need a few factors, like they're also optimal location for data centers because they depend mainly on fiber optics, access to water, and access to power, as well as permitting and so on. So And it depends which type of data center, because you have data centers for AI, but also other types of data centers. So then there are other factors as well, like the distance to the user. But the main factors that usually apply are the access to power, which is the grid, but also you need capacity, like basically load. Then there is the fiber optics and water access in some cases. So because of this, it depends on the location as well, and there are better locations for these projects.
So you said water a couple of times there. Are data centers thirsty?
They use it for cooling.
Uh-huh. So like when you're using water for cooling, can you just use the same water and just recirculate it over and over again, I guess, probably? Maybe it's a good way to make a hot tub. Right? They should
Well,
have
in fact,
spas, data center spas. Yeah.
it's a great point, because there were some projects, for example, in Denmark and in Canada, I think from Meta, one of them, that they did a partnership with this centralized heat company. I think it was from the government of Denmark, and they were providing heat for the heating the water for houses in Denmark, and was kind of a good way of recycling the waste heat of the data centers. But this was super project specific. I don't know if it's still active.
Yeah, I hear there's somebody up in Northern California, like Sonoma County or something like that, making Bitcoin hot tubs. And I guess Bitcoin mining is sort of a data center of sorts. And also I've heard that there's some kind of saunas or hot tubs in New York City that are also powered by Bitcoin miners, which are
Wow.
like servers. So it only makes sense.
That's interesting.
that,
It's the
you
same
have-
concept.
Yeah. You
Yeah.
have waste heat, and then why not use it?
Yeah,
You know?
exactly.
I mean, it would be
This-
kind of dumb not to. Well,
Yeah, this project in Canada I'm speaking about, the one in Denmark was to heat water, but the one in Canada I think was for a greenhouse of strawberries. So they also need this heat, and they recycle it through that. But yeah, like there are good examples. But yeah, these huge hyperscalers is something different sometimes. Like they now need velocity and volume to put these projects in place because of the AI demand around the world, because now it got to the hands of everyone. And that's why there is this huge growth.
do you know like what temperature a data center works at? Like when there's waste heat, how hot is it? Because it would only get you that hot. Like let's say that my favorite hot tub temperature is 40 degrees C, 104 Fahrenheit. And if the data center works at 103, I'd be out of luck. And if it works at
Yeah.
105, that would work great. Or
So
maybe 110 would
I'm
be
not
better.
an expert, but I did research in the past. In fact, I was researching this topic even before going all into replace. I had this idea like 6 years ago. And that was one of the problems, because it's not that hot. So then it's difficult to convert that heat into energy, because you need to then heat it up the last mile. But if I'm not mistaken, the maximum heat that you get is like 70 degrees Celsius, like 70, which is pretty hot, but was not enough to
Yeah,
create
not
power again.
Not enough to make steam. You have to get to 100. Yeah.
Exactly.
Okay. Interesting. So I've thought about that too, where people are trying to combine together solar PV and solar thermal. And one of the problems is that you want the PV to be a lot cooler than you want the thermal to be. So like if you're running water behind solar cells, as the water heats up, then it's heating up the solar cells instead of cooling them down towards the end.
Interesting.
Towards the last couple of cells there. So you know,
maybe it's a good point, because then you have this concept of floating solar, and one of the advantages is that the water keeps a cool temperature on the panels and improve efficiency. So you touch into a good point, because this is the opposite.
Yeah, and you're probably not worrying too much about heating up that water, but with your data center, it's like you probably want to run as cold of water as you can get into it, like perhaps just like right above freezing. And then when the water is recirculating, it's going back to the intake, then it might be warmer than you want it to be, especially like if you're trying to heat up a hot tub or something like that.
Yeah.
And I think too that like hot tubs are very important.
Honestly, in some areas, it can be a great idea to use this heat to it to water, because then you can save power and use it for another purpose, even powering the same data centers. There is a huge concept now also of like selling heat instead of, because a lot of industries buy energy to then produce heat for their whatever industrial process, but you could get directly the heat. And it's a big thing in places where the grid is stuck, where there is no capacity in the grid.
So I would think it would probably make more sense as far as like using it for heating would be in a colder place. So, you know, like Iceland, or you were saying Denmark and those types of places. Like if you had waste heat in places like Arizona, it's not like you're going to be heating your house with it. You know, like
no, exactly.
I guess like, what are you going to do with this? It's not super hot where it's going to be used for like industrial processes or steam or spinning turbines. I guess perhaps another thing though, is if you were making steam, like say that there was some kind of like concentrated solar thermal or some kind of like thermal energy storage, then you could preheat the water. So like if you're going to go to make steam, instead of starting at 20 degrees Celsius, which is 68 Fahrenheit, you could be starting more like 40 degrees, which is 104, you know, or 70 degrees, which I don't have that at the top of my head, but it's a lot hotter. And it's hotter than you want to be. Maybe
that can
sauna
be the
temperature.
solution to create energy, but I don't know if it's cost efficient at the moment. But yeah, the bottom line is, at that point when I researched it in the past, that there was this issue that then it's not really scalable. So it was more project per project. As you are saying, it's kind of project per project. But yeah, like it's maybe going back 1 second, like something I read that is super interesting is that because of all this, because of this data center boom and also industries growing in the US, the energy demand, it's growing in a similar like percentage than what happened after the Second World War ended and the soldiers went back to the US. And this is the first time since 1943 that happened. So it's like a big thing, this delta on the demand growth on the power side in the US.
And then are you seeing it mostly being solar and as far as the plans go and things like that? Or are the oil companies successful in their political lobbying, and are they getting people to, you know, do more fossil fuels?
Look, without getting political now, I was in RE Plus in Vegas a few weeks ago, and the outcome was that everyone was talking about storage, solar, and data centers. But on the solar side, there was a bigger conversation on M&A, in merger and acquisitions. And a big reason is because of the One Big Beautiful Bill that impacts the IRA and impacts differently certain technologies, and the oil and gas industry keeps subsidies while the solar subsidies are impacted in different ways in residential and in utility scale. And that creates a huge change because suddenly some projects become not viable. But also on the other hand, there is huge opportunities if you have cash to acquire, because people that have big portfolios may not be able to progress with all the projects. So there is a lot of change going on.
Yeah, and I think too, a lot of people are talking about like, oh, all the tax credits are going to expire at the end of 25, which is not true, because if a project is owned by a corporation, then you get a couple of more years, because corporations are a lot more important than people, don't you think? That's why they have more rights and better tax credits.
I mean, maybe what you are mentioning is the difference between residential, that it's by the end of this year.
Yeah, and even residential, a lot of residential is owned by corporations, so they still get it as long as it's financed, like through a corporation.
As far as I understand, but in utility scale, then there are like different milestones, because you have the safe harbor point, and then you have until operation. So my reading of the market, and we're talking to tens of developers every week, and basically the game continues. Like solar, and in some cases the cheapest form of power, and also in some cases the fastest to build, and to from zero to providing power to the grid the fastest and cheaper, which is a huge advantage, even though it's intermittent and it has its things, even though in some cases these subsidies are threatened, these developers are still doing greenfield. Maybe some developers are reconsidering their strategy, but the medium and big are still doing greenfield. And but as I was saying, the M&A market is booming. And in every Plus, again, everyone was talking about M&A. My feeling was that developers were there to meet other developers to learn about deals. So it's a very interesting moment on that aspect.
Do you think that since you're dealing also with data centers, how price sensitive are the data center people? Like they just want to get their data centers up, and is the price of electricity kind of something that's not driving anything? And they're just like, whatever it costs, we're going to pay for it. Is it that important? Like, we got to get the AI up. We got to make our stock grow. We need that electricity. And if it's going to be 10 cents a kilowatt hour, 20 cents a kilowatt hour, just get it. Are they kind of looking at it like that way?
It's a great point, and also like it's difficult to generalize because you have different sizes of data centers. One thing is Google, and another thing is if we build a small one in California together, for example, it's a totally different case. And we work mainly with the hyperscalers, so the energy developers that do co-development with data centers. So it's not that I deal directly with these power purchase agreements, but from what I see, they are less sensitive than other industries regarding the energy price. Because the motivation is basically, if you don't get those kilowatts, you will not be able to develop your project, and the whole project is on the line. So it's a key factor, and that's why basically they are less sensitive. Even they are still sensitive because it's one of the main, like a very impactful cost in their operation, the energy cost.
Do any of the companies that are doing the data centers, like those big tech companies, are any of them looking at being solar and storage developers themselves?
It's a great point. And let's talk also about other power sources, because as you may have seen, like OpenAI and Meta and so on, and their founders are investing in some nuclear companies, in some geothermal companies, which tells us that the energy aspect is strategic for them. Right now, as far as I know, they are not developing solar energy projects themselves. They are more doing this PPA, these power purchase agreements with solar developers, and you see across the board, if you Google Google PPA for data center, you will see a bunch of deals they did with different type of developers to secure that power. So right now, what I'm seeing is that they are not developing the projects themselves. But this being said, their founders, like Berg and Sam Altman from OpenAI and so on, are investors in startups in nuclear and geothermal, which tells us something on what they are thinking for the future.
So I think probably with nuclear and geothermal, it's a long way out. I mean, you could talk like it might be 10 years. And like, who knows what the world's going to look like then. And I'm kind of wondering too, if part of that could just be, let's make a statement and like, please all these people that like nuclear, but are they contracts too, and things that they might not be spending a whole lot of money on, and it might be something that they could back out of, and maybe they're sort of just hedging their bets. It just seems like, they're doing this AI stuff where a year is too long to develop some electricity. And then all of a sudden they're talking about these types of electricity generation that takes 10 years, or at least historically has. And of course they're going to say like, oh, we could do it faster. And then you go back historically too, and it's like when they were going to develop a nuclear power plant 30 years, 20 years, 10 years ago, they would say like, oh, we're going to develop it in half the time that we used to, and then it doesn't happen.
In fact, yeah, you have a great point. In fact, I'm thinking out loud with you, and you have a great point. I agree. Like, if the technology will be ready, the project will be slower. But also, we need to consider the technology readiness level. So, yeah, like, look, to solar and wind, coupled with storage, are key to provide net zero data centers. That's for sure.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
I can also remember too, like there was a company called SolarSEAN, and they had a contract to provide space-based solar power, that's microwaving it down, for PG&E, that's the utility where I live, biggest utility in the country. And they were going to beam it from space, from geostationary orbit down to Earth. And they had a contract for 2016, and it didn't happen. And I don't know if anybody really even thought it was going to happen with that time frame, but it looked good to sign a contract. And it also probably maybe helped advance space-based solar power a little bit, because people are like, oh, this is real. There's a contract for this. But of course, there's like with any contract, you can write it up however you want, and there could be ways out of the contract. And so
it will be interesting to see the details.
Perhaps with the nuclear too. And it's like nuclear gets a lot of people excited. And it's like, I would think probably somewhere around half of the people in the solar industry are for nuclear, another half hate it. And, it's like, it's the way that people develop bombs by nuclear power plants. I'm trying to build one in my basement, so it's just like really controversial. And a lot of people have spent a lot of money on all these other types of energy besides solar. And it seems that solar and storage are the way that it works. And then, we talk about the tax credits expiring, but, of course, the main part of the tax credits have a couple of years left, and then a couple of years is a long time, and they could bring him back. It's like, it's like, who knows who's going to be running the world in a couple of years. A
lot going on, but the bottom line is it's impact the industry for sure. But it's, as I was saying, like we spoke about storage and solar, but and data centers a lot, but the big thing also we're seeing in the industry, even a bit before the bill, the One Big Beautiful bill, is this increase in M&A. Like, M&A, developers buying and selling projects under development on the secondary market. So let's say you started a project, you got the land, you got few permits. I'm talking about utility scale projects, but you have a few of them, but you need to put the deposit to progress on the grid process, and that's maybe a $50 million deposit, or not deposit, I mean like to go to the next phase. But you have 3 projects, so you need a bunch of money. So you decide to sell one of them. And that's happening a lot right now. So there is a huge boom in this secondary market of renewable energy projects, which is being done mainly by word of mouth, or which means like through network, or by lawyers and investment bankers. It's like kind of developers don't see the full picture while doing an acquisition. And there is a lot of work to be done there, and technology can add a lot of value over there.
So if I wanted to like buy one of these projects that's under development, how much money do I need? Do you think I have enough?
Look, it depends a lot on the size, but it depends where it is, how advanced it is, but it's directly related to the progress in terms of interconnection, permitting, and one thing is if it is at NTP, like notice to proceed, and one other thing is if you only have the land and submitted an interconnection request and you have commercial operation date, COD, in 2030, like it's a completely different story. So that kind of the way to understand the value.
So where are you seeing a lot of action? Is it like in the desert areas, Texas, East Coast?
So it's a great question, because it depends. Like, for example, community solar is having more action in certain area. Like there was a lot of action. Like, of course, Texas, California are always like hot markets, and because Texas is deregulated. But like for community solar, for example, Illinois was very big last year. Now storage is going big in places like New York, state, and Illinois, and always Texas is part of the picture as well, and California, of course. But just giving you some highlights. But it depends a lot. Like, we speak with a lot of developers, and the huge developers, like these multi-billion-dollar companies, they work in every single state. And then there are other developers that their strategy that are experts in Texas, for example, or in PJM, or in WEC. So it depends a lot. And it's related to our previous topic of data centers as well, because there is a lot coupled to that because of the growth of demand. But for the M&A side, for example, we see a lot in PJM happening. And it depends when, because, for example, now there was every few months there is a new release of the interconnection phases. So now there was a release of TC1 phase 3 in PJM. So it tells the new results in the transmission cycle 1. And then there is information, and then there is action, because you have a deadline to decide if you continue or not. And if you don't, you may like to sell your project because you don't want to lose it.
Mm-hmm.
So
Right.
it's really dependent on when and for who, to answer your question on where there is more action.
Okay. I was wondering too about data centers. The load is, I'm sure, variable, but how variable is it? Like, is it when Monday morning when everything turns on is probably like maybe a peak, and then in the middle of the night on a Saturday, maybe it's kind of slowed down? How is it like, is a peak 50% more than the slowdown, or how does that look with the load profile?
It's a great point. I'm not an expert on load profile in data centers. What I see from the developer's side is that they require energy security, let's say, like they need to have constant access to energy as a given because they need to be reliable for the customers. But about the profile, I'm not the one to answer that question.
Yeah, so I had somebody on the podcast, Stephen Smith, and he had a way to do a Google search where it didn't use the AI so he could save energy. I think what was it, like minus AI before his search?
You can do
Something
it.
like that.
I didn't know.
Yeah, let's see if I think that was it. So if I go minus AI, and I'm not getting any, just with Google, I put minus AI and then a search, and then it's not, spending all that extra energy.
That's interesting. It's more environmentally friendly search.
Yeah.
It may be a thing in the future.
I know, and sometimes I kind of miss the old searching. Like, I wonder, like, I get so used to searching with AI that it's like I have a different method of doing things.
Yeah. It's crazy how fast it's changing our behavior.
Yeah. So let's see, what else do you have going on, or like what kind of people are you looking for, connecting with, that kind of stuff?
Yeah, so basically developers and investors of renewable energy projects and data centers in the US, mainly in the utility scale side. And the big news, as I was telling you offline at the beginning, is we are like our main technology of site selection for renewable energy projects is growing, but we also added a new module to identify M&A opportunities on the queue based on LLMs, talking about AI, which is booming. Like, we are seeing huge demand for it, and we are super excited about it.
Yeah, there's a lot going on with all this AI stuff and lots of opportunities. In fact, maybe the timing of the AI boom is kind of perfect with getting rid of the tax credits, because it's like you lose the tax credits, but then you get the AI boom. And so it's sort of like it evens out.
That's true.
Yeah.
It's a positive way to see it, and I like it, to see the things on the positive way. So, yeah.
Yeah.
And also coupled with the fact that, for example, solar can be the fastest way to produce new electrons in the grid and the cheapest. So,
yeah, for sure. So the future is bright.
yeah.
I'd much rather be an optimist than a pessimist,
I
Got to look at the
completely
bright
agree.
side, and especially in this
completely
industry.
agree.
Okay.
Yeah.
Anything else you want to talk about right now, or want to tell people where they can find you and how they can get your assistance at some M&A or solar projects and stuff like that?
Yeah, no. Thank you, Sean. This was great to talk again with you. And yeah, I'm Matias Sigal on LinkedIn, Matias Sigal. And my email is matias@renewableenergy.place. So we'd love to discuss about M&A for renewables and greenfield development and also data centers, as we were talking a bit today.
All right. Well, thank you so much, Matias Sigal, CEO and co-founder of Replace, where you can get all your M&A stuff done. And I really enjoyed talking to you about data centers and how that works with the solar industry. And I think that we do have a very bright future. And to make your future brighter, you should get yourself NABCEP certified and learn more about solar. You could go to SolarSEAN.SolarSEAN.com and get yourself one of those NABCEP certifications. All you have to do is go to SolarSEAN.com and you put a / of your favorite NABCEP initial. So you got PVA, PVIP, PSIP, and all of the others. So thank you very much, Matias Sigal, and thanks for listening. Woo!